My name is Katie O'Donoghue and I'm a senior at the University of South Carolina.
I am majoring in mechanical engineering at UofSC.
My name is Ehsan Faiq. I'm a PhD candidate in chemical engineering.
I am a mechanical engineering major.
It's an amazing opportunity to work with smart young people throughout your life. And you're always talking with people that are excited, looking into the future, want to contribute, want to change the world, especially in engineering computing.
I started working with composites at the McNair Center.
I had to program in 5 different languages. I had to fabricate things in the fabrication shop.
I find that there's a transition that happens right around the second year for an undergrad. It's almost like this light just goes off.
We have been undergoing great growth in our College of Engineering and Computing. Since 2006 till now, our enrollment has more than tripled to over 3,200 undergraduates. Our graduate enrollment has grown. Through federal agencies, etc., of course, we continue to grow our research. We have had over 50% growth in our research funds. The intentional growth has been in areas of energy and water, in transformative health, transformative computing, connected and smart cities, and agile manufacturing. And we are fortunate to be in a state which is also a manufacturing state. And those are areas that we too are trying to align ourselves with the growth of the state.
I'm focusing on batteries in my research, mostly zinc-based batteries. So I do a lot of work on alkaline batteries where the anode made from zinc electrodes. And I'm focusing on how we can increase the energy density and also lower the hydrogen gas evolution in alkaline batteries.
Energy is one of these grand challenges. And so our group works in electrochemistry, which really is the discipline of directly utilizing electrons instead of combustion. And so, our work can be applied to storing wind power, storing solar power. We also can enable hydrogen vehicles, fully electric vehicles.
My project came from a company, so I'm really getting some results that they want to use in actual applications of batteries. That's really interesting for me and it's encouraging, which I'm satisfied with that.
I learned a lot of, I'd say like critical thinking. So like how to not just go to my boss and say, hey, how do I do this? But I can like figure it out myself and go to my boss and say, hey, this is my idea, here's why.
Currently, we are in the era of what we identify as Manufacturing 4.0 or Industry 4.0. At the University of South Carolina, we conduct research where we're trying to come up with concepts such as the digital engine that will actually try to replace virtual commissioning and will try to replace and enhance productivity by making robots and humans work better together.
Being at McNair, I get to talk to so many people who work on many disciplines, and it's really reassuring that to see how to communicate with those people. Like I'm a mechanical engineering major, and if I was to talk to a person who majored in computer science, I know how to talk to them. I know what I want from them.
The foundation and success of the college is the ability to work with different departments that are geared towards creating a success story.
The College of Engineering and Computing has strong research programs in both chemical engineering and mechanical engineering. So it was a very natural fit for those two areas of strength to come together and form a biomedical engineering program. The faculty within the program are interested in things like tissue engineering, drug delivery, drug discovery, biomarker development, as well as cardiovascular mechanics, looking at things like forces required for plaque rupture and elasticity of vessels.
One of the things that the university did recently was they started an excellence initiative, and part of that was they decided to fund a university-wide institute for artificial intelligence. We already had about 45 to 50 faculty who are dabbling in the field of AI within their disciplines. So we needed a glue that puts it all together. The institute plus the 10 faculty that we are going to hire into it is that glue.
I think I'm most excited about the unknown. It's kind of like I could do anything. Like I feel like I could work with airplanes or I could like build a fan. Like it could go from like big to small, and I think it's really cool that I have such like big opportunity for whenever I graduate. The world's my oyster, baby.